In the next 3 videos, we're going to look at the UK water sector's regulation experience. A novel form of economic regulation of privatised utilities emerged here. It offered the promise of a simpler, less intrusive approach than the rate of return regulation approach that Dale just described in the previous video. So we're going to focus on economic regulation here, leaving aside environmental, social and customer-related regulations. In this first video, we'll describe what was novel and promising about the economic regulation approach suggested for the privatised England and Wales water industry. In the second video, we'll then describe how the economic regulation approach worked out in practice. In the third video, we'll explore how regulation may enable or constrain possibilities for innovation to address future challenges in the water sector. We showed this slide previously in our session on the UK water privatisation experience. These are the various stakeholders that make up the privatised water sector in England and Wales. There are separate economic, environmental and social regulators. Here the economic regulator is Ofwat. As Dale has said, in an industrialised country setting like England and Wales, the economic regulator of a privatised water utility is mainly concerned with preventing abuse of natural monopoly power by controlling what water prices can be charged to customers who are not free to choose their water company supplier, given that there is no competitive market. So typically here we are talking about economic regulation to keep prices down, unless there are compelling reasons for prices to be allowed to rise within certain limits, for instance to fund improvements to the water service. When we discussed the UK's water privatisation experience, we saw it was an outlier of sorts. The UK government chose full divestiture privatisation of the England and Wales water industry, a rare option. The UK is also an outlier because of its water sector economic regulation approach. Within the UK's broader privatisation programme, a novel approach of price cap economic regulation was invented. This economic regulation approach was then adopted for setting water prices in England and Wales. It's called RPI-X price cap regulation. RPI stands for the Retail Prices Index and is a measure of the rate of inflation. X is an efficiency challenge. We'll give more detail and a worked example about this later in this video. Just as we saw a key individual, a Mr. Privatisation, in the UK water privatisation story, there's also a Mr. Regulation in our UK water regulation account. This is Professor Stephen Littlechild. He's a Fellow of the Judge Business School, University of Cambridge, and Emeritus Professor at the University of Birmingham, where he trained in the UK, as well as the University of East Anglia, and in the USA at the University of Texas at Austin. Professor Littlechild was a member of the Competition Authority, the Monopolies and Mergers Commission in the UK from 1983 to 1988, and the inaugural Regulator or Director General of Electricity Supply from 1989 to 1998. He now consults internationally on matters of privatisation, regulation and competition in various utility sectors. Professor Littlechild was a central figure in the invention of RPI-X price cap economic regulation. John Stern of the London Business School has described the 1983 Littlechild report as one of the most famous but least read economic papers. The 1983 Littlechild report developed an idea about having a temporary cap on price changes in the UK telecoms sector, at a fixed rate below the Retail Prices Index, or RPI, measure of inflation, specifically the rate of inflation, or RPI, minus 2%. This would be until a competitive telecoms market emerged that would incentivise telecoms companies to set their prices competitively. Littlechild modified this idea for a temporary, fixed price cap rate below the rate of inflation into a flexible price cap, or RPI-X, that could be used for different utility sectors, not just telecoms. And it could be used permanently to provide an efficiency challenge in utility sectors where competition might not emerge. RPI-X is a price adjustment formula. It is applied to the initial price paid by customers for the utility service. The X factor is determined through the process of economic regulation. Having a flexible X factor in the price adjustment formula instead of a fixed percentage meant that a utility company can make a bid to the economic regulator for the X it wishes to charge. By bidding for a particular X factor, the utility company is bidding for a future price rate that will either adjust its initial price upwards or downwards relative to the RPI-based measure of inflation. So a utility company might bid to adjust its initial price to customers at a rate below the RPI measured rate of inflation if it believed it could still meet its required targets by charging a reduced price in real terms. Or a utility company could bid to adjust its initial price to customers above inflation if it knew it had to invest, say, to improve its utility networks, so much that it would have to charge its customers an increased price in real terms. So Littlechild took a specific idea for a temporary price adjustment cap on telecom service prices of RPI minus 2% and turned it into a new, general approach to price cap regulation that could be applied to any privatised utility sector. Renowned economist John Stern has said of the publication of this intellectual innovation in the 1983 Littlechild report that the world of utility regulation economics and policy making would never be the same again. There have also been 20th, 25th and 30th anniversary events and academic journal special issues to celebrate Professor Littlechild's intellectual innovation in the field of economic regulation. RPI-X price cap regulation has since been used in utility sectors in Australia, New Zealand, Latin America, parts of Europe and in some US telecoms regulation. And in 2005, a portrait of Professor Littlechild was part of an exhibition in the UK's National Portrait Gallery in recognition of his contributions. Before the Littlechild reports, the prices that privatised utilities could charge were set by the regulator using the rate of return approach. This is where the economic regulator sets a rate of return on capital investment for the privatised utility that tries to mimic the price that would yield this rate of return. As Dale has mentioned, a drawback is that a privatised water utility's capital investment plans therefore need to be scrutinised in great detail by a regulator. This is to avoid unnecessary capital spending, given that rate of return regulation rewards capital spending. So, for example, a privatised water utility may build assets not because they are strictly needed or demanded by customers, but rather because doing so increases its rate base upon which it is permitted to earn a return. It may also build assets that far exceed required operating standards to increase its rate base. This is known as gold plating, and overcapitalisation in general is called padding a capital programme. With price cap regulation, instead of capping the rate of return a water utility can earn, the average price that can be charged is capped for a particular set of services for a specified period. A regulator receives bids for X from the privatised utility companies to decide how to set limits on prices, so, in theory, it does not need to get involved in onerous micromanagement of scrutinising utility as to whether its specific, case-by-case, individual capital investments are warranted or not. And, as Professor Littlechild himself has argued, the regulator is mainly concerned with the factor that is of greatest concern to customers, which is the price of the water services for which they are paying. RPI-X price cap regulation accounts for inflation pressures. If inflation was not taken into consideration, a privatised utility subject to price caps would be increasingly penalised by any increase in the nominal prices of its factor inputs, such as labour, electricity and chemicals. Littlechild's solution to this problem of inflation was to allow the privatised utilities prices to adjust to inflation. That's the RPI element in RPI-X. RPI-X sets a general expectation for efficiency improvements over time. The regulated utility has to outperform the general inflationary trend in the wider economy, and it has to do so by a certain percentage specified by the X factor. Otherwise, the regulated utility will make a loss as the real prices, net of inflation, will fall over time as inflation proceeds. It will not be able to recover costs incurred as a consequence of being inefficient because it cannot raise its prices above the efficiency challenge price level that has been set for the specified period. To account for changing circumstances over time, the X factor rate can be reset periodically. Let's now go through an example of how RPI-X price cap regulation works. Here are our assumptions. Let's assume an initial price for water of £3 per cubic metre. This is about what I pay for water and wastewater services. Then let's assume a forecast RPI inflation rate of 3%. And let's assume a water company bids for an X efficiency challenge value of 1%. This is the water company revealing to the economic regulator, Ofwat, that based on its own efficiency estimates, it believes it can adjust prices next year 1% below the forecast rate of inflation. Let's assume Ofwat accepts this bid. So what does this mean that the water company can charge its customers next year? Here's how the RPI-X price cap economic regulation would work out. The price cap for the next year would be the initial price plus the price adjustment. And the price adjustment would be the RPI-X multiplied by the initial price. So the price cap would work out as the initial price multiplied by 1 plus the RPI-X. You can pause the video here if you want to work this out for yourself. For this example, the price cap, or the price that the water company can charge its customers next year, is £3.06. So this example has looked at a price cap for the next year. But in the England and Wales privatised water sector, following some initial issues that we'll look at in the next video, the price cap cycle was set at 5 years. A price cap is determined by the economic regulator, then stays in force for 5 years. and at the end of the 5 years, water companies bid again for their individual X factors. The economic regulator determines the final X values, and a new price cap period runs for the next 5 years. The price cap is understood to be the maximum prices that it is acceptable for water customers to have to pay. If there are no new regulatory tasks that the regulator wants the private water companies to undertake, like meeting higher drinking water quality or environmental quality standards, then the expectation will be that the price cap should be a below-inflation price adjustment. In other words, that water prices should fall in real terms, thus forcing private water companies to become more efficient over time. But if essential investments are needed in the next 5-year period, the price cap could include an above-inflation price adjustment. So water prices charged to customers are the main lever here of control for the economic regulator. And they should be the primary concern of the water utility companies too. And water prices will be of high importance to customers. And in theory, as we've said, the details of capital and operational spending are left for the managers of the privatized utility companies themselves to manage, and do not have to be scrutinized and approved in detail by a regulator. Let's look now at how the X-factor bidding process works. Step 1, shown here by the dotted red line, is for the economic regulator to forecast the likely RPI inflation for the forthcoming 5 years. Step 2, shown by the solid red line, is for the regulated water companies to make a water prices bid to the regulator. This is their offer of X. That will lead to their price cap, based on the price adjustment their X implies to their initial price. So this step 2 is the water company telling the regulator how efficient it thinks it can be during the 5 years, by revealing the water prices it wants to be able to charge to cover its costs, while still making a reasonable profit for its investors. This, of course, is a strategic moment for the water company. Do you think it would want to reveal its true X to the economic regulator? There are several information and information asymmetry issues to consider here. First, the water utility may not have all the information it needs to know precisely how efficient it can be over the coming years. Second, from outside the company, the economic regulator may have even less of an idea of how efficient the water company could be. The water company may choose to exploit this information asymmetry, or may choose to err on the side of caution about its efficiency estimates when it makes its X-factor bid. In step 3, shown by the dotted orange line, the economic regulator then sets the price caps. This is where the regulator decides to accept the X-factor's bid for by the water company, or to challenge it. But how does the regulator know whether to accept or challenge the water company's X bids, without scrutinizing the details of the water company's business plans? In the England and Wales case, the economic regulator Ofwat does this through benchmarking, which we'll come to later. And the water companies know Ofwat will do this benchmarking, so they perhaps have an incentive to make a true X bid. In this illustrative example, the price adjustment set by the regulator is below the forecast rate of inflation. So this example represents a challenge to the water company to be more efficient than it originally bid. In practice, there's also a right of appeal built in here if the water company believes the final price limit set by the regulator is unachievable. Step 4, shown by the solid blue line, is for the company to try to outperform its RPI-X price adjustment during the 5 years of this price-setting period. The incentive here is that if the water company can become more efficient and reduce its costs below the cost levels assumed by its price adjustment, then it can continue to charge its customers based on the price adjustment associated with its assumed costs, rather than what the price adjustment would be if it were recalculated with the more efficient actual costs, until the new price-setting process in 5 years' time. So it profits from outperformance for the 5 years, shown by the green arrow here. Conversely, if the water company performs less efficiently than its assumed costs, then it still has to charge prices to customers based on the original price adjustment, and the company's shareholders will have to bear the cost of the company's poor performance until the end of the 5-year price-setting period. So the water company may have to reduce its dividends to shareholders and so forth, making it less desirable to stock market investors. Step 5 is that the price-setting period begins again and the process repeats. The economic regulator here takes into account the actual performance levels of the water company in the previous 5-year period, when it decides whether to accept or challenge the water company's next bid for a new X factor for the next 5-year price period. This maintains a challenge to water companies to keep becoming more efficient over time, and it maintains the incentive for water companies to do so because they get to keep any profits due to outperformance for 5 years in the next cycle too. Let's look now at how can the economic regulator know whether to accept or to challenge a water company's bid for an X factor. How can the regulator know a water company's bid is reasonable without getting into the details of water companies' business plans? Because if it had to do that, it would nullify the benefits of simple RPI-X price cap regulation, say over more intrusive rate of return regulation. Professor Littlechild wanted this information to be revealed by a process he called rivalrous discovery. He wanted rivals, here that means multiple water companies, to have to compete for water customers, and for water companies to discover how to become more efficient in that process of competition. But how could this work in England and Wales with a set of large, regional, monopoly, privatised water companies? This slide shows the operating boundaries of the 10 main large regional monopoly water and sewerage companies created at privatisation in England and Wales in 1989. There are also some smaller water-only company boundaries shown here. Benchmarking the performance of the 10 main water and sewerage companies, and also the smaller water-only companies, could substitute for Littlechild's rivalrous discovery process here. The idea would be that each water company would reveal information about the water prices it thought it had to charge to cover its costs and make a profit by bidding for a particular X factor for each price-setting period. If each water company could have its own individual X factor, then this would reveal relative efficiency information. Individual water companies could then be benchmarked against each other. This is also known as yardstick or benchmark competition. The UK government, through its golden share arrangement that prevented foreign takeovers until 1994, and Ofwat, through its duty to scrutinise the value of any mergers taking place in the sector, resulted in no mergers taking place between the large water companies. This preserved a base of 10 large companies for Littlechild's rivalrous discovery process to play out. Some water companies did want to merge, arguing that they could achieve economies of scale by doing so. But Ofwat highly valued the importance of retaining enough comparator water companies to benchmark against each other. In my research, I've been told the Ofwat Director General, Sir Ian Byatt, who in statutory terms was the economic regulator at the time, with power to make the executive decisions, indicated that any merger between the 10 large water companies should have to demonstrate around £1 billion net benefit for it to be worth doing. Clearly, he felt that all 10 of the large water companies were vital data points for Ofwat's comparative benchmarking process. There are 3 important problems, though, with this yardstick competition approach. First, it can be distorted by pack behaviour or even collusion. Imagine, all the water companies could simply set their ambitions very low and say all ask for price caps that did not challenge them to become much more efficient. Then if all water companies performed inefficiently, how can one benchmark them to incentivize them to improve? Second, if all water companies get more efficient over time but experience diminishing returns until they eventually reach some efficiency limit, what happens then? Without innovation, no company might ever exceed this efficiency limit. Then all water companies' performance levels would become indistinguishable, and simply benchmarking them would not incentivize them to improve over time. Third, if the benchmark is based on particular key performance indicators, then the water companies could simply choose to become very good just as measured by these indicators, and leave other efficiency improvements aside. In other words, the regulator's performance measure could be captured by the water companies. The water companies could all eventually score near 100% on this benchmark score measure, but then not continue to improve in other respects over time. In all 3 instances here, comparing the water companies' performance to each other loses its incentive value. The Ofwat data in this slide arguably shows one or possibly all of these 3 processes at work. The lines plotted here show the Overall Performance Assessment, or OPA, scores achieved by the England and Wales water companies. OPA was a composite indicator of Ofwat's key performance measures of water supply, sewerage service, customer service and environmental performance. It includes things like risk of low water pressure, unplanned interruptions, drinking water quality, properties at risk of sewer flooding, response to written customer complaints, and response to telephone-based customer contacts. Let's assume here that these performance levels were revealed by the water companies themselves, again not requiring intrusive scrutiny by Ofwat. The OPA scores are shown here for 3 successive price reviews, in 1999, dark blue, 2004, magenta, and 2009, light blue. On the left are the 3 lines for the scores of the 10 large water and sewerage companies at these 3 successive reviews, and on the right are the lines for the smaller water-only companies. Each water company is a data point on the line for that particular price review year. Overall, in these 10 years, across the 3 price reviews, all water company OPA scores improved. But they also became more similar. This reduces their value for benchmarking. For instance, in 1999, the worst performing large water companies, shown here with a red circle, were clearly distinguishable from the best performing ones, shown here with the green circle, having about a 30% lower OPA score. In this kind of performance league table, the worst performing companies look bad to their shareholders and to their customers, to the media and to politicians. With lower performance levels, these are the water companies where it is likely that the economic regulator Ofwat would challenge their price bids. For instance, how could a poorly performing water company defend its bid for price increases when it may need to increase prices due to being inefficient, rather than due to increased cost requirements, say, to meet higher levels of service? Conversely, Ofwat may be more inclined to accept the price bids by the water companies it knew were performing well here. It might trust that their price bids were justified, given their past good performance. By 2004 and 2009, the magenta and light blue lines here, it becomes harder to see this kind of clear performance difference, and perhaps harder for Ofwat to base its decisions to accept or challenge price bids by water companies that are only 10% or so different in performance levels. There is also a fourth problem with this benchmarking approach as a way for the economic regulator to decide whether to accept or challenge water company price bids under the RPI-X approach. That's the problem of whether you want to view the water sector in isolation or to benchmark its performance more broadly. Back in 1998, Ofwat commissioned consultants to consider this kind of problem. Consultants explored whether you can benchmark water company performance against non-water comparator sectors. This slide shows some of the consultants' suggestions. They considered potential benchmark industries that were comparable in terms of processes used, scale of operations, or similarity of products and services. For example, perhaps efficiency trends in the soft drinks industry might be a relevant benchmark for water companies, or those for the dairy products industries. These are process industries delivering consumable foodstuff products, after all, with some similarities to water supply service. To the best of my knowledge, this research has not altered Ofwat's benchmarking processes, and whilst separately, Ofwat also keeps abreast of developments in water sectors elsewhere in the world, as far as I've seen, this is only through qualitative comparisons, and does not lead to direct efficiency challenges for the England and Wales privatised water companies. In this video, we've reviewed a novel approach to the economic regulation of privatised water utilities to prevent abuse of monopoly power through excessive water price increases to customers. RPI-X price cap regulation offered the promise of a less intrusive approach than rate of return regulation. Water companies would bid for their desired adjustments to their initial water prices based on their own management decisions about costs and capital investment levels. And the economic regulator would be able to decide whether to accept or challenge water companies' price adjustment bids by benchmarking water companies' performance against one another, based on performance levels published by the water companies themselves, rather than the economic regulator having to gather this information, and the economic regulator would not have to scrutinise costs or capital investments on a case-by-case basis in detail, say to avoid the risks of padding or gold-plating of water companies' rate bases. And all of this would be made possible in the England and Wales water privatisation case because there were multiple comparable water companies available for benchmarking. There are two serious issues, though, with the theoretical RPI-X economic regulation approach we've just described. First, remember that RPI-X is a price adjustment formula. It is critically dependent then on the initial price that one adjusts from. But the RPI-X formula does not enable you to determine the initial price from which you then adjust. So let's say a privatised water company is permitted to adjust from a high initial price. It may then be less worried about being given a below-inflation RPI-X price adjustment. But a water company starting from a low initial price may later become unable to finance its functions if it's given a below-inflation RPI-X price adjustment, say at the same time as being required to undertake a program of capital investment to improve its networks to meet higher drinking water and environmental quality standards. Second, Ofwat's OPA measure did not exist at the time of privatisation of the England and Wales water industry in 1989. So at privatisation there was no standardised benchmarking information that Ofwat could use to accept or challenge water company price bids. Together, these two issues meant that the RPI-X price cap regulation was never used in the England and Wales privatised water sector exactly as Littlechild may have originally envisioned. and the use of RPI-X economic regulation has not been simple or non-intrusive in reality. That's what we'll look at in our next video. Thanks for watching.